Hello everyone. Welcome back to Dr. Liu's VCE Physics channel. Today, let's learn together about the 2025 NHT Physics examination. We will focus on questions related to light as a wave. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. The line QP is the perpendicular bisector of the speakers, meaning the path difference is always zero. This creates a path of permanent constructive interference. Rather than hearing alternating quiet spots, Sam would simply hear the sound level gradually increase as she nears the speakers. This makes C the technically correct answer based on the provided geometry. To find the length of the string, we need to look at the relationship between wave speed, frequency, and the geometry of a standing wave fixed at both ends. First, we use the wave equation to calculate the wavelength of this standing wave. Second, we determine the string length with standing wave equation. For a string fixed at both ends, the fundamental frequency, the first harmonic, occurs when the string forms a single loop. In this state, the length of the string is equal to exactly half a wavelength. So, B is correct. Mila is studying Young's double-slit experiment, which can also be done using microwave radiation instead of visible light. The separation of the centers of the slits, S1 and S2, is 10 centimeters, and the distance from the slits to the line PQ is 1.5 m. A microwave detector is moved along the line PQ, and the maxima and minima in microwave intensity are recorded, as shown in Figure 15. As this is a double-slit experiment, the wavelength of the microwave radiation can be determined using the standard interference equation. Given that point Y represents the first-order maximum, the value for n is 1. By rearranging the formula to isolate the wavelength and substituting the known variables, we can calculate the final value for the microwaves. Point Z is a location of destructive interference because the path difference between the waves arriving from S1 and S2 is equal to 1.5 lambda. This causes the waves to arrive out of phase, effectively cancelling each other out and resulting in a minimum microwave intensity. Point Y will remain a maximum. By doubling the microwave frequency, the wavelength is halved to 1.4 centimeters. The path difference to point Y was originally one wavelength, 2.8 centimeters, to produce the first maximum. With the new wavelength, this fixed path difference now corresponds to exactly 2 full wavelengths, 2 lambda. Since the path difference remains an integer multiple of the wavelength, constructive interference occurs, maintaining a maximum at that location. When the frequency is doubled, the wavelength is halved, causing the interference pattern to compress toward the central maximum, W. Since fringe separation, delta x, is directly proportional to wavelength, lambda, all maxima and minima move closer together. The original position of point x, the first minimum, corresponded to a path difference of 0.5 lambda old, 1.4 centimeters. With the new wavelength of 1.4 centimeters, this path difference now equals exactly 1 lambda nu. Therefore, point x will shift from a minimum to a maximum. The electron double-slit experiment provides evidence for the wave nature of electrons by demonstrating an interference pattern. Since interference is a phenomenon unique to waves, observing this pattern proves that matter can exhibit wave-like behavior. Multiple choice question 14. Two-source interference, sound, analysis of the perpendicular bisector line QP confirmed that the path difference remains zero. This creates continuous constructive interference, meaning the sound level gradually increases due to proximity rather than alternating in loudness. Multiple choice question 16. Standing waves on strings using the relationship L equals 0.5 lambda. A string with an 8.00 Hz fundamental frequency and 40.0 meters per second wave speed was calculated to have a length of 2.50 m. Short answer question 11. Double-slit interference, microwaves. The wavelength was determined to be 2.8 centimeters using the formula at the first maximum. Doubling the frequency halves the wavelength, causing the interference pattern to compress and shifting the original first minimum, point x, to a new maximum. Short answer question 15. Wave-particle duality. The electron double-slit experiment provides definitive evidence for the wave nature of electrons by demonstrating an interference pattern, a phenomenon unique to wave behavior. Should you require assistance, please feel free to connect via WeChat or WhatsApp and send an email. Thank you for your attention. Kindly note the details of Dr. Liu's VCE Physics, Chemistry, and Biology channels.